Good morning, students. Myself R.B. Suksare, lecturer as a MTED department. Now, here in this video, we will see a revision class on first chapter Introduction to Mechatronics. Here, what is mechatronics? The mechatronics word is composed of mecha from mechanical and the tronics from electronics. Mechanical plus electronics, that is mechatronics. The word is mecha plus tronics, mechatronics. Here the term mechatronics is used for this integration of microprocessor control systems, electrical systems and mechanical systems. A mechatronics system is not just a combine of electrical and mechanical system and is more than just a control system. It is a complete integration of all of them. Mechatronics brings to give areas of technology involving sensors and measurement systems, drive and actuation system, analysis of the behavior of systems, control systems and microprocessor systems. Example, consider the modern of autofocus, auto exposure camera. To use the camera, all you need to do is point it at the subject and press the button to take the picture. The camera automatically adjusts the focus so that the subject is in focus and automatically adjusts the aperture and shutter speed so that the current exposure is given. Next one, that is the mechatronics. Next one, system. What is meant by system? Here the system is in this diagram input, process, output. Input is electric power, motor is process, output is rotation of shaft. That is the system. Okay. In mechatronics, the system involves what are termed systems. A system can be thought of as a box which has an input and an output, and where we are not concerned with what goes on inside the box, but only the relationship between the output and the input. Thus, for example, a motor may be thought of as a system which has its input electrical power as an output the rotation of the shaft. This is system. Next one, measurement system. What is measurement system? Here in this diagram, example of measurement system, the measurement of thermometer. Input is temperature, thermometer process, output is number on scale, varying on scale. That is the measurement system. Here can be thought as a box which is used for making measurements. It has its input, the quantity being measured, and its output, the value of that quantity. Example, here in this measurement system, the thermometer. Here the thermometer measurement system, that is a thermometer, has an input of temperature and an output on a number on a scale. That is an example of thermometer system. Next one, example of control system. Control system. Here the example of control system is the maintaining the temperature. Input is required temperature, central processing heating system, and output is the temperature at the set values. Here the control system can be thought of as a black box which is used to control its output to some particular value or particular sequence of values. Example 1, domestic central heating control system, as in its input the temperature required in the house and as its output the house at the temperature. That is, you set the required temperature on the thermostat or controlled, and the heating furnace adjusts itself to pump water through radiators and so produce the required temperature in the house. That is a control system. Next one, what is mechatronics measurement system? The measurement system can in general be considered to be made up of the three elements, that is sensor, signal conditioner, display. That is the three elements. Here quantity being measured, sensor the quantity being measured, signal conditioner and display the values, that is value of quantities. Here this sensor which responds the quantity being measured by giving as its output a signal which is related to the quantity. Example, a thermocouple is a temperature sensor. The input to the sensor is a temperature and the output is an electromotive force which is related to the temperature values. Next one, signal conditioner. Takes the signal from the sensor and manipulates it into a condition which is suitable for either display or, in the case of control system, for use to exercise control. For example, the output from a thermocouple is rather small electromotive force and might be fed through an amplifier to obtain a bigger signal. The amplifier is the signal conditioner. Third one, a display. A display system where the output from the signal conditioner is displayed. This might, for example, be a pointer moving across a scale or a digital readout. As an example, consider a digital thermometer. This has an input of temperature to a sensor, probably a semiconductor diode. The potential difference across the sensor is at constant current. A measure of the temperature, this potential difference is amplified by an operational amplifier to give a voltage which can directly drive a display, the sensor, and the operational amplifier may be incorporated on the same silicon chip, that is measurement system. And here the next one, the difference between open loop and closed loop system. Here open loop system, in this diagram the input process output, but there is no feedback. But here closed loop system, input process output but feedback is arranged, that is open loop and closed loop system. Here the main difference is, to illustrate further the difference between open loop and closed loop system, consider a motor. With a open loop system, the speed of rotation of the shaft might be determined solely by the initial setting of a knob which affects the voltage applied to the motor. Any changes in the supply voltage, the characteristics of the motor as a result of temperature changes or the shaft load will change the shaft speed but not the compensated for. There is no feedback loop. With any closed loop system, however, the initial setting of the control knob will be for a particular shaft speed, and this will be maintained by feedback regardless of any changes is supply voltage, motor characteristics, or load. Here, in an open loop control system, the output from the system has no effect on the input signal. In a closed loop control system, the output does have an effect on the input signal, modifying it to maintain an output signal at the required values. Open loop systems have the advantage of being relatively simple and consequently low cost, with generally good reliability. However, they are often inaccurate since there is no correction for error. Closed loop systems have the advantage of being relatively accurate in matching the actual to the required values. They are, however, more complex and so more costly, with a greater chance of breakdown as a consequence of the greater number of components. In mechatronics, the example of sequential control system. Sequential control system. Here the main components are washing machine control system. Washing machine, here the main inputs are clocks, program, and control unit. The processors are pump, valve, heater, motor, washing machine drum, processing, and correction elements are pump, valve, heater, motor. And outputs are water level, how much water level is there, water temperature, how much water temperature is there, drum speed, rotation of speed, door closed, open or closed system, that is the outputs. Here there are many situations where control is exercised by its being switched on or off at a particular preset times or values in order to control processes and give a step sequence of operations. For example, after step 1 is complete, then step 2 starts. When step 2 is complete, then step 3 starts, etc. As an illustration of sequential control, consider the domestic washing machine. A number of operations have to be carried out in the correct sequence. These may involve pre-wash cycle, when the clothes in the drum are given a wash in cold water, followed by a main wash cycle. When they are washed in hot water, then a rinse cycle. When the clothes are rinsed with cold water a number of times, followed by spinning to remove water from the clothes. Each of these operations involves a number of steps. For example, a pre-wash cycle involves opening a valve to fill the machine drum to the required level, closing the valve, switching on the drum motor to rotate the drum for a specific time, and operating the pump to empty the water from the drum. Operating sequence is called a program. This sequence of instructions in each program being predefined and built into the controller used. In washing machine, the system that used to be used for the washing machine controller was a mechanical system which involved a set of cam operated switches, that is mechanical switches. Thus the cams are means by which the program is specified and stored in the machine. The sequence of instructions and instructions used in a particular washing program and determined by the set of cam chosen. With modern machines, the controller is a microprocessor and the program is not supplied by the mechanical arrangement of cams but by a software programs, that is the washing machine functions. Thank you, one and all. Thank you.